Hello everybody. Recently I got some new glassware, so now we can use it. Today we'll be conjuring up iron oxide solution, various bleaches, and potentially sodium hydroxide. The main reason for doing this video, however, is to get the iron oxide. As you can see, using this new glassware, I can use proper measuring techniques and get an exact amount of salt. I was very proud when I had the perfect amount of salt to water ratio. However, I made quite a few mistakes, and this ratio was eventually very skewed, more so to water. A very big mistake that introduced many mineral impurities was using non-distilled water. This water comes from treatment plants and has many minerals in it from rivers, other places, and also from the treatment plant itself. Oftentimes, chlorine is added to water in order to kill off bacteria. This could greatly impact our results, as the product could be very impure from all the impurities in the water, so it's best to use distilled water rather than the sink water. A major mistake I made was adding water to the salt, created a very thick solution which was able to get stuck onto the beaker. I had to rinse it several times in order to get the salt off and into a mixing flask. This is where the salt to water ratio was ruined, such that there would be more water than salt. As you can see, the saltwater solution is so thick. However, I liked how it was. It was perfect until I had to add more water. Another issue was that the mixing flask was way too large. This required me to add more water in order to fill the flask a bit. This way, we could actually do mixing in it instead of just having a bunch of drops of water at the bottom. The water was very hot. Vapors were condensing in the neck of the mixing flask. This caused the flask to fog up. I would like you all to keep in mind that this solution will change colors many times in this video. The end color is going to be very different from the beginning color and demonstrates a chemical reaction. After vigorous mixing, I dumped out the mixing flask back into a beaker. At this point, you can tell my saltwater solution is very dilute and not very foggy anymore. Some salt was left in the mixing flask, but our saltwater electrolyte solution had been prepared. It was now time to electrolyze it in a well-ventilated area. It was very cold on this day, which is not ideal, so some of the salt crystallized out of the solution. Yet again, the solution required vigorous mixing. This time, however, I used a stirring rod. I broke all my graphite electrodes in my pocket. That was very funny. Graphite electrodes can be extracted from pencils. This is very difficult and often leads to them being very short and broken, which is not ideal. Now I had to remember what the LEDs meant on LED. LEDs only go one direction. This makes them very good for testing which is negative and which is positive. Determining which end is positive and negative is very important, as the iron needs to be at the cathode in order to destroy the bleaches. This is very important to the setup, as I wanted to use two different electrodes. We would use an iron electrode to produce iron oxide and also destroy any bleaches that may form. The graphite electrode is very inert and would not cause anything to happen to the reaction mixture. In short, we would give very pure sodium hydroxide solution and also dissolved iron oxides. Or at least this was the plan. This is by far my favorite shot. You can see the chlorine bubbles rising. You can also see the other product, which is hydrogen, at the graphite electrode. I find that the bubbles at the iron electrode looks the best. After a short period of time, the water became foggy again. This strange white color was unprecedented, as the color before had been clear, transparent. There was no color, it just looked like regular water, with a slightly crystalline appearance. The water began to take on a slightly more whitish yellow color. This was expected, as the yellow should be coming from the rust. However, we find out later that this was not from the rust, necessarily. This may have been from some kind of strange abomination we created, a byproduct, potentially something from the water not being distilled. The water became even more foggy. Visible rust appeared in the water, However, this rust was not from the electrode, this was from the alligator clip. It fell in, and decided that it would oxidize in the water. At this point, however, I began to question whether we actually had water anymore, or that's what I should have been questioning. Finally, the water took on a red appearance. This red-brown appearance indicates many iron oxides have formed. At this point, the electrodes no longer were coated in bubbles. This indicates that the electrolyte solution had been exhausted, essentially meaning that we'd ran out of fuel for this reaction, and it was time for the final step. This is not coffee. I would not drink this. This smelled terrible. It looks terrible, and would probably stain your teeth red, give you tetanus, and make you miserable. The culmination of all of our work so far was an absolute failure. Paper towels are designed to be highly absorbent, and are not designed for filtration. The result of this was that the paper towel decided it was going to drip everywhere. Thankfully, I had my notebook underneath of it, and thankfully my notebook is somehow waterproof. But surprisingly, the final product, the water, was very clear. We put water in quotation marks here because this is very questionable, whether this is water or not. I will go into more details on that later. However, we successfully filtered the iron oxides out of this liquid, but rather than filtering, we actually absorbed them into the paper towel, as well as some of the liquid. I thought I may be able to recover some of the iron oxides by drying the paper towel. However, this just left me with a very bleached, very dried paper towel. This filtration, however, was very nice to look at, and I quite enjoyed it. What I'm pretty sure happened is that I got the anode and cathode mixed up. These involve the electrodes. Initially, I put the iron at the anode instead of the cathode. This means that bleaches would have been formed at the graphite cathode, where we intended the iron to destroy them. Basically, this means we made sodium hypochlorite, or something like that. In fact, the liquid smelled quite like bleach, and was very unpleasant. I would like to thank you all for watching, and have a great Sunday.